Welcome back guys, I hope all of you will be fine. So this is question 3.41 and the statement of it is a candy company distributes boxes of chocolate with a mixture of creams, toffees and cordials. Suppose that the weight of each box is 1 kilogram but the individual weights of the creams, toffees and cordials vary from box to box. For a randomly selected box, let X and Y represent the weights of the creams and toffees respectively. Okay, so let me first write the given data, and in the given data we can write here that the weight of each box is 1 kilogram, that is understood, and also the creams and toffees have been represented with X and Y. Okay, so let me write here creams weights are represented with X and weights of toffees are represented with Y. Okay, so these are the two given things, and also the total weight, which includes creams, toffees and cordials, are composed of a one box which is of 1 kg. Okay, so suppose that the joint density function of these variables is given by fxy, where 224xy is the density function which lies in between the ranges of x greater or equal to 0 and less than or equal to 1. The range of y is greater or equal to 0 and less than or equal to 1, and the combined weight of x and y can be less than or equal to 1. Okay, and it is 0 elsewhere. So on the basis of it, what do we have to do? We have to find the probability that in a given box the cordials account for more than half of the weight. Okay, so in solving the part A of our question, we have to find the probability that cordials are what? Their weight is more than 1 by 2 or half of the weight, so that is greater than 1 by 2. Okay. But here we can very easily see that the joint distribution or joint density function doesn't encounter the cordials, it is only including the weights of the creams and toffees. So therefore, if the weight of the cordials is greater than 1 by 2, so it means the combined weight of x and y will be less than 1 by 2. So what I can do here is that I can here very clearly see that it will be x plus y will be less than or equal to 1 by 2. Okay, so it must be understood in this way. Okay, so it will be like this one. So now in order to find this probability, what do we have to do? We have to find the probability that x plus y will less than or equal to 1 by 2. So we can use here for this addition, we can very clearly see that this is a continuous function. So for it we can use the integration. Okay, so for integrating it we have to use different ranges of x and y. So if the y range is from 0 to 1 by 2, so the range of x would be from 0 to 1 by 2 minus the weight of a y. Okay, so this will be subtracted from 1 by 2. Okay, so now writing the function here, and that is 24 x y. Okay, and also integrating it with respect to x and integrating it with respect to y as well. Okay, because now we have been adding the two functions, so therefore I have to add them together by using the integration, which is for the continuous functions. Now here 0 to 1 by 2 and integrating it first with respect to x. Okay, this part. So what will we get here? We will get 24, and here this is with respect to x, so x square divided by 2, and here we will have y. Okay, and also it will be from 0 to 1 by 2 minus y, and integrating with y is left. Okay, so now it will be 12. Okay, and also putting these values, what I will get here, I will get 12 will be outside, and here it will be 0, 1 by 2, and putting these ranges here, I will get 1 by 2 minus y whole square. Okay, and also this y here, and then dy. Okay, so this is for this one. Okay, this is the function we have got. Now after it, using the integration by parts, okay, so integration by parts for this one, for dy, at the end putting all the limits and all the values, what I will get at the end, the answer of it will be 1 over 16. You can use here integration by parts by yourself and see that the answer of it will be 1 by 16, and that is what, that is the solution of part A of my question. Okay, so I hope you have understood it. Now moving somehow downwards, okay, and now seeing part B of my question. Okay, so what is part B? Find the marginal density for the weight of the creams. Okay, so weight of the creams are represented with x. Okay, we have seen that, and for it, let me find the marginal density for it, and let me represent it with g of x. Okay, so let me find it out, and finding it out, I have to define the limits for the function which is here. So it will be from 0 toward for any value which will be less than 1 kg, because if it will be composed of the cream, the other items will also be included. So those would, the weight of the cream will be subtracted from 1, which is the 1 kg. So therefore it will be from 0 to 1 minus x, the quantity of the creams subtracted from the 1 kg. Okay, so now writing here the values 24 x y, and now again integrating it with respect to dy. Okay, so now using it, and what I will get here, I will get 24x, and here this will become what, y square divided by 2, and here 0 1 minus x. Okay, so now it will become 24, and this will become 12 here, so I will get here 12. Okay, and here 12x, and putting 1 minus x and 0 here, so ultimately I will get 1 minus x square, and that is for the marginal density for x, or weight of the cream. So that is what we have found out. This is the answer of part B of my question. So also the range of x will be here, what we have to define the range of x as well. So the range of x will be greater or equal to 0, and it will be restricted less than 1, because all other items will also be included. So I am not making it equal to 1. So that is the solution of part B. Now moving to the part C of my question, find the probability that the weight of the toffees in a box is less than 1 by 8 kg. Okay, so let me first write the given data here. We have to find the probability that the weight of the toffees in a box is less than 1 by 8, and we have seen that the weight of the toffees were represented with what, that those were represented with y, and creams were with x. So therefore the weight of y is less than 1 by 8 kgs. Okay, if it is known that creams constitute 3 by 4 of the weights, and given here is that creams which are x, these are of 3 by 4, we have to find it out. Okay, and we can very clearly see that this is the case of a conditional probability. Okay, because one probability has been given, and on the basis of it we have to find the probability of another item, which is the case of the conditional probability. Now using it and finding it out, the formula we have already known for the conditional probability is the p x and y divided by the probability of x. Okay, y x, because here you can see that this probability is given, so this will be written here, and those two items has been included here as well. Okay, so we can see it here as well. Now writing their values, do we know the probability of x, y? Yes, this is the same thing which is already given in the question. We can see that this is what, this is already given here in the question, which is 24xy. Okay, let me write it here, 24xy. Okay, and the probability of x, do we know it? Yes, that is also the marginal density which we have here, and that is 12x 1 minus x. So 12x 1 minus x square. Okay, So these two will cancel out, this will be 2, and ultimately I will get what? I will get 2y divided by 1 minus x whole square. Okay, so that is what? That is the formula for the conditional probability which is given here, and here we have to consider the ranges of x and y as well. So putting those values here, okay, so putting the values of x and y here, because the value of x is already given, so putting this 3 by 4 here, what I will get here, the probability that y is less than 1 by 8 such that x is equal to 3 by 4. Okay, so here now putting the value of x, which is 3 by 4, so I will get 2y divided by 1 minus 3 by 4. Okay, so this will be squared. Okay, so I will get here 2y divided by 1 minus 3 by 4 is 1 by 4. So this will become 1 over 16, which will be 32 y. Okay, so this is what? This is for the marginal density of this one. Okay, so this is for 32y, and now in order to find the value for that instance, what we have to do, we have to integrate our value from 0 to 1 by 8. Okay, so now integrating it from 0 to 1 by 8, because we are going to find the marginal density, so here it will become 32y dy. Okay, so now it will be 32 into y square divided by 2, and it will be from 0 to 1 by 8, and ultimately solving it, what I will get? I will get here 1 by 4. Okay, so the answer of this is 1 by 4, which we have already found out. Okay, so that is basically the solution of part C of my question, in which we have seen that how can we find out the conditional probabilities or conditional density function from any given data. Okay, so you have understood that after finding the conditional probability formula from it, I have to integrate it in this range, because no any restricted range has been defined, but this is the cumulative range, and for that I have to integrate it as well. Okay, therefore I had integrated in, and the formula given me the answer, which is 1 by 4. Okay, so that's it for today, in which we have seen the solution of question 3.41. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.42, and the statement of it is, let x and y denote the lengths of life in years of two components in an electronic system. Okay, if the joint density function of these variables is given by fxy exponential of minus x plus y for x greater than 0, 1 greater than 0, and 0 elsewhere, find the probability that the lifespan of x is greater than 0 and less than 1, given that the lifespan of the component y is equal to 2. Okay, so again this is another problem which corresponds with the conditional probability. Okay, so let me solve it, and in solving it, if you want to solve this one, what do I have to do here? The given function is here. So if I want to find out the probability of x given that y is equal to 2, what do we have to do here? We have this thing, and here in order to find it, we have to use the conditional probability. So in conditional probability, what do we have to do? We have to find the probability of x and y divided by the probability of y. Okay, we want to find these quantities here, and then putting it here, we will get the answer which is here. Okay, but here we have one thing, and that is this one. This is given and it is here. Okay, but we don't know about probability of y. Okay, so now in order to find this one, let me find it out here, and the probability of y would be equal to what? As we have previously found out, finding it out, we know the range of y. So in order to do so, integrating it and then finding the probability of y, we have to write here fxy, and integrating it with respect to what? With respect to x. Okay, Also putting the limits here will give us the answer. Now let me write the value of xy. So integration, the value of xy is exponential of minus x plus y and dx. Okay, also putting the limit here, and the limit we already know is y is greater than 0, so 0 up to infinity. Okay, so let me integrate this one and find it out, and here also we can see that this is from 0 to infinity. Okay, and here it will also be minus x multiplied by minus y and d of x. Okay, so as we have been integrating it with respect to x, so this exponential of my will be treated as a constant. So putting it outside of this integral and then integrating this exponential of minus x, what I will get, it will be minus x divided by minus 1, and here we will have 0 to infinity. Okay, so here exponential minus exponential of minus y because of this negative sign, and here putting these limits, what I will get here, I will have exponential of minus infinity minus exponential of 0. So ultimately the answer of it I will get is exponential of minus y, and this is what this is for the probability of y. Okay, so as I have found it out, let me put these values here in this formula. Do I know the value of probability of x y? Yes, it is already known, and it is here exponential of minus x plus y, which can also be written as exponential of x plus y divided by this value. This is exponential of minus y. Okay, or exponential of minus x into exponential of minus y divided by exponential of minus y. Okay, these two will cancel out, and ultimately what I will get here, I will get exponential of minus x. Okay, so that is what, that is the answer of this question, in which I want to find out the probability of x given that y is equal to 2. As y is already cancelled out here, therefore I am not going to write the value of y, so the answer of it will remain the same. Okay, so that is what, that is the answer of this one. But now you can see that I don't want to find out the value of x, but I want to find out the probability that it lies within this range. Okay, so now in order to find this value, what do I have to do? I have to take the same value, okay, which is this one, and to find out it within this range, what do I have to do? I have to integrate it within this range 0 to 1. Okay, and then writing the value which is minus x and integrating it with respect to x, and it will give me what? It will give me the probability that x is greater than 0, less than 1, given that y is equal to 2. Okay, so let me integrate it, and finding the answer of it, what I will get? I will get here exponential of minus x. Okay, this will be minus as well, and here 0 to 1. Okay, ultimately what I will get here, I will get 1 minus exponential of minus 1, which is 0.6321. Okay, so that is what, that is the answer of the question which we had here. Okay, so that is the probability that x is greater than 0 and less than 1, given that y is equal to 0, and that is already found out here. So that's it for today, in which we have seen the solution of question 3.42. If you have any question, you can ask me in the comment box. See you soon. Hello guys, I hope all of you will be fine. So this is question 3.43, and it is saying that let x denote the reaction time in seconds to a certain stimulus and y denote the temperature in Fahrenheit at which a certain reaction starts to take place. Suppose that two random variables x and y have the joint density function which is represented with fxy, which is 4xy for the x which ranges from 0 to 1, and for y which ranges from 0 to 1 as well. Okay, and it is 0 elsewhere. So on the basis of this data, what do I have to find out? I have to find out two parts of it. So let me start solving it, and in solving part A of our question, what is this? I have to find out the probability that x is greater or equal to 0 and less than or equal to 1 by 2, and y is greater or equal to 1 by 4 and less than or equal to 1 by 2. Okay. So, how can we find it out? Let us find out. So, probability of x greater or equal to 0 and less than or equal to 1 by 2, and also y greater or equal to 1 by 4. On the instead of and, I can also put here this comma. So, therefore, this will be y greater or equal to 1 by 4 and less than or equal to 1 by 2. How can we find out? So, for each of them I can use certain integration. So, for it I have to use the integration from 0 to 1 by 2, and for it I have to integrate the function from 1 by 4 to 1 by 2. Okay. So, using these two integrations, what will happen here? I will have here, let me first write here the integral for y. So, it is 1 by 4 to 1 by 2 and then x, okay, which is 0 to 1 by 2. Why did I write here y first and x second? Let me explain it to you as well. So, the function here is 4xy. So, 4xy is here, and after it I have to write which function. As you can see here very clearly that here I have written this x. So, therefore, I have to use here the integral with respect to first, and after it what is the integral? You can see that here this is 1 by 4. So, therefore, I have to put here d of y. Okay. So, I have put here d of x second because I can very easily use this function. Okay, this will be easier for me to calculate, and then finding the limits here, it will give me the answer very easily, and after it I can use the integration for y. Okay. So, let me solve it, and first finding the integration for x. For that function, this 4 and y will become the constant. So, here I will have 1 by 4, 1 by 2, and this 4 and y will be outside, and here I will have 0 to 1 by 2 x dx and dy. Okay. So, let me move down somehow. Okay. So, moving somehow downwards and writing here 1 by 4 to 1 by 2. Okay, and here we have 4y, and here this will become x square by 2 multiplied by x square divided by 2, and the limits of it are 0 to 1 by 2 and d of y. This will be here, and here I will have 1 by 4, 1 by 2, okay, and here 2 x square, which is from 0 to 1 by 2, and here this y, okay, and dy. Putting these values here and then finding it out, what I will get here, it will become 1 by 4 minus 0. So, it will become 1 by 4, 1 by 2, and here it will be 1 by 4 multiplied by 2, it will become what? It will become 1 by 2, and here we will have y. Okay. So, this is what? This is the function I have to integrate later on. So, now integrating this y with respect to y, what I will get here, this 1 by 2 is a constant, and integrating it with respect to this, what I will get here, I will have y square divided by 2, and limits are from 1 by 4 to 1 by 2. Okay. So, this is what we have. Okay. So, these two will become 1 by 4. So, let me move down somehow as well. Okay. So, it will become 1 by 4. Okay, and putting these limits here, what I will get, the higher limit is 1 by 2. So, 1 by 2 square is 1 by 4 minus this 1 by 4 square, this is 1 by 16. Okay. So, solving it, this will become 1 by 4, and here this is 16, and here it will be 4 minus 1 Okay, so ultimately I will get 3 over 64, which is the answer of part A of my question. Okay, this is the solution of part A of my question. You have seen that how to find it out, and the essence of this basically lies in this formula which we had here. Okay, we had used it and we have found it out. Now on the basis of it, the part B is to find the probability that x is less than y. Okay, so the probability that x is less than y. So in using formula for this one, what do I have to do? We can see that y can have any value while the value of x will be dependent upon this y. Okay, so let me first write the integration for y, and that can have any values from 0 to 1, because this is the range of y. Okay, this can have any value, and this is for this one, and here it will be dy. Let me have this value. Now after it, when it will get any value out of this one, the y should be dependent upon it, and it will get all the values which has the limit from 0 until and up till this y. Okay, I hope you have got my point that it will not be larger than this y. Okay, so that's why I have used it. So now here 4xy and here d of x. Okay, so this is what the concept of this question is. So let me solve it. This will become 0 1 first solving this integral which is here. Okay, let me use this color for it. This is this one, first solving this one, and solving it, what I will get, this will become 4y x square divided by 2, and this is from 0 to y, and here dy. Okay, so these two will cancel out, here it will be 2, and here I will have here 0 1, and this will become 2y, and putting this limit here I will get y square, and it will become dy. Okay, so I hope you have got the concept of this solving it. Okay, so now it will be 2 0 1, here it will be y cube dy, which will be 2 into y4 divided by 4, 0 to 1, this will be here, and here I will have 1 by 2, which is now 1 raised to power 4 minus 0 raised to power 4. Okay, which will ultimately give me 1 by 2. Okay, so the solution of part B is 1 by 2. So which is the probability that x will be less than y, and this is 1 by 2. Okay, so that is basically the solution of part C of part B of my question. This is the overall solution of question 3.43. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.45, and the statement of it is, let x denote the diameter of an armored electric cable and y denote the diameter of the ceramic mold that makes the cable. Both x and y are scaled so that they range between 0 and 1. Okay, suppose that x and y have the joint density which is given by fxy, and that is 1 by y for the values of x which is greater than 0 and less than y, and y is greater than x and less than 1. Okay, and that is 0 elsewhere. So what do we have to do? We have to find the probability that x plus y is greater than 1 by 2. Okay, so now solving it, let me solve it here. So here I want to find out the probability that x plus y that is greater than 1 by 2. Okay, so now in order to find it, we can very clearly see that in terms of CDF, it can also be found out by using the 1 minus probability of x plus y is less than 1 by 2. Okay, so let me find it out, and here we can see that both the values of x and y and the summation of them should be less than 1 by 2. So in order to make this happen, what do we have to do? Let me take the value of x from 0 to 1 by 4 such that the summation of x and y will be less than 1 by 2. Okay, so now let me take the integral so that the first integral will range from 0 to 1 by 4, which is for x. Okay, so this is d of x. And also another integral which is for y, we can see the range of y which starts from x and will end at less than 1 by 2, where the summation of both of them will be 1 by 2. Okay, so it will start at x and will end at what? It will be 1 by 2 minus x. Okay, I hope you have understood that the summation of both of them will be less than 1 by 2. Okay, so this will be what? This will be d of y. Now writing the value of the function which is 1 by y, and that is here. Let me solve it, and here solving it we can very easily see that this is 0 to 1 by 4, and solving it we can see that this will be what? This will be natural log of y. Okay, this will be natural log of y, and range of it will be x to 1 by 2 minus x. Okay, and that would be d of x. Now putting values here, what I will get? 1 minus 0 to 1 by 4, and putting values here I will get natural log of 1 by 2 minus x. Okay, minus natural log of x d of x. Okay, at the end, integrating it and solving it all, what we will get, the answer of it will be 0.6534. Okay, and that is what, that is the solution of question 3.45. The only thing you have to understand here is this formula. We have used the range of x from 0 to 1 by 4 because x plus y will be less than 1, and here you can see that the y range will be from x to 1 by 2 minus x. Okay, so this formula is very important for you to understand that how we integrated it and how did we find out the value which we have here. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.46 of chapter 3, which states that referring to exercise 3.38, find A, the marginal distribution of x, and B, the marginal distribution of y. Okay, so this question is basically most relevant to the marginal distribution of the exercise problem of 3.38. So let us see that what was basically the exercise problem 3.38. I will also put the link of it here, okay, in this corner, so that you can watch it for your revision as well. Also the link of it will be available in the description as well. Okay, so let us see that what was that problem related to. So here you can see that this is problem 3.38, which is if the joint probability distribution of x and y is given by this one, okay, for the values of x which are 0 1 2 3 and y 0 1 2. Okay, so on the basis of it, what did we found out for the values of x 0, y 0, the value of the function is 0, the value of x when 0, the value of y is 1, the value of the joint probability distribution as 130, and so on. Okay, so this was a table we had generated in this question, and let us take this table and put it in our current problem. Okay, so let us copy it and paste it there. So pasting it here, we can see that this is basically the table which we had. So let me take it and put it here. Okay, so this is the table we had. So now let me see that here we have the value of x 0, so then the values of y's are given here. For the values of x1, the values of y are also given here as well. So in part A, what do we have to find out? We have to find the marginal distribution of x. Okay, so for x, when the value of x is 0, we have to do what? We have to add them all. Okay, so here adding them all, what will I get? Here I will have to add 0 plus 1 by 30 plus 2 by 30. Okay, because this is for x, so I have to take the value of x constant and y values are changing. Okay, so adding them together, it will be 3 by 30 or it will be 1 by 10. Okay, so for x equal to 0, the marginal distribution of x is 1 by 10. Okay, similarly for x equal to 1, I have to add them together now. So let me add them, and here it would be 1 by 30 plus 2 by 30 plus 3 by 30. Okay, so adding them all together, the LCM of it will be 30, and 1 plus 2 plus 3 is 6. Okay, so ultimately it will give me 1 by 5. Okay, similarly here x is 2, so here adding the values of y here, so I will have here 2 by 30, 3 by 30 and 4 by 30. Adding them all together, what I will get, the LCM of it will be 30, and 2 plus 3 plus 4 is, how much is this? This is 9 by 30. Okay, so it will become 3 by 10. Okay, similarly this one. Okay, now adding them together, LCM is again 30, and it will be 3 plus 4 plus 5, so 5 plus 4 is 9, 9 plus 3 is 12. Okay, so it will be 2 divided by 5. So these are all the values for the marginal distribution of x. So now after taking all these values, which are for different values of x, I have to tabulate it here in the form of the, let me call it x, value of x, and let me represent the marginal distribution of x as g of x. Okay, so now the values of x are 0, 1, 2 and 3. Okay, let me put the corresponding values here. So it will be 1 by 10, here this is 1 by 5, this is 3 by 10, and the last one is 2 by 5. Okay, so this is the solution of part A of our question, in which we can see that this is the marginal distribution of x. Now let me move towards part B of our question, and let me remove these values. Now for the marginal distribution of y, what do we have to do? We have to take the constant value of y and add them together, all the values of x which represent that value. Okay, so here the constant value of y is 0, while the values of x are 0, 1, 2, 3, and for the corresponding values of the joint density, what do we have to do? I have to add them together. Okay, so adding these values, I will have 0 plus 1 by 30 plus 2 by 30 and plus 3 by 30. Okay, so adding them together, what I will get here, it will be 30, and 1 plus 2 is 3, 3 plus 3 is 6, so it will be 1 by 5. Okay, so this is what, this is for y is equal to 0. Similarly for y equal to 1, what do we have to do here? I have to take these values and I have to add them together. This is for y equal to 1, so I will have here 1 by 30 plus 2 by 30 plus 3 by 30 and plus 4 by 30. Okay, so taking the LCM, which is 30, adding all these values, so 1 plus 2 is 3, 3 plus is 6, 6 plus 4 is 10. Okay, so it will be what? It will be 1 by 3. Okay, so this is for y equal to 1. Now for the value of y equal to 2, what would I get? Let me do it here. Here the LCM again is 30. Okay, and values here would be 2 plus 3 plus 4 plus 5, so 2 plus is 5, 5 plus 5 is 10, 10 plus 4 is 14 divided by 30, so ultimately it will be 7 by 10. Okay, so these are the values for y equal to 2. Okay, now taking it and plotting it as we had previously done for x, so here we have y, and let me represent the marginal distribution for y as h of y. Okay, so let me put these values here, and here putting these values for the values of y, which are 0, 1, 2, and putting their values here, it will be 1 by 5 as found out here. For 1, this is 1 by 3 as here, and for 2 we have 7 by 10 as we have done here. Okay, so this is 7 by 10. Okay, so the answer of our questions are, okay, which we had found out by using the tabular form here, from which we have found the marginal distributions for x and y
from the density functions. Okay, so that's it for today. If you have any question, you can ask me in the comment box. We will try to solve more questions relevant to this type of problems as well. So thank you so much, and I will see you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.47, and the statement of it is the amount of kerosene in thousands of liters in a tank at the beginning of any day is a random amount y, okay, from which a random amount x is sold during that day. Suppose that the tank is not resupplied during the day, so that x is less than or equal to y, and assume that the joint density function for these variables is given by fx of y, which is 2 for the ranges of x which is greater than 0 and less than or equal to y, and y greater or equal to x and less than 1 and 0 elsewhere. Okay, so on the basis of this statement, what do we have to find out? We have to determine that if x and y are independent or not, and b, probability of x is greater than 1 by 4, less than 1 by 2, given that y is equal to 3 by 4. Okay, so in order to solve it, let me first solve part A of my question. Okay, and here, in order to see that when would these two random variables be independent of each other, we have to see that whether g of x is equal to h of y or not. Okay, so what is this? These are basically the CDFs. So let us first find g of x. So in order to find the g of x, we have to integrate the fx of y, which is 2, with respect to what? With respect to y. Okay, so when I will integrate it with respect to y, I have to put here the limits of y as well, which are from x to 1. So therefore here it will be x1. Okay, or ultimately I will get here, from here I will get what? You can solve it and you will see that here I will get x minus 1 for the range of x greater than 0 and less than 1. Okay, this is for g of x. For h of y, I have to perform the similar operation for the same fx of y, fxy, which is 2, but here I have to integrate it with respect to x. Okay, therefore I will put the limits of x which are from 0 to y. Okay, so here I will have 0 to y. Okay, and ultimately I will get here what? It will be 2y for the y which is greater than 0 and less than 1. Okay, so these are the two required quantities I have found out, and putting them here I will see that g of x is not equal to h of y. Okay, what it says that the two variables x and y are dependent upon each other and are not independent of each other, which is also prominent from the statement of this question as well. Here we can see that, and this basically says that the two random variables are basically dependent of each other. Okay, so that is for part A. For part B, I have to find out the probability of x is greater than 1 by 4, less than 1 by 2, and for the given that y is equal to 3 by 4. So for it, I have to first find out the probability of x given that the probability of y. Okay, so it can be very easily found out here, and that would be from the conditional probability, and it would be probability of xy divided by the probability of y, which is basically h of y. Okay, putting it here I will get here. Now putting their values here, the probability of xy is 2. Okay, and the value of it is 2y. So ultimately I will get here 1 by y. Okay. Similarly, now putting values here which are from for the values of x is greater than 1 by 4, less than 1 by 2, and y is equal to 3 by 4. So let me first put this value here. So putting this value here, what I will get, it will be probability of x given that y is equal to 3 by 4. Okay, and it is 1 by y. So putting values here, I will get here 4 by 3. Okay, which is the value of y here. Now in order to find our required quantity, which is probability of x greater than 1 by 4, less than 1 by 2, so here it will be the ranges of x which are 1 by 4, 1 by 2, okay, given that y is equal to 3 by 4. Okay. So we have this value here. So just I have to put the limits here, which are from 1 by 4 to 1 by 2. Okay. And here we have what? Here we have the values which are 4 by 3 and d of x. Okay. So now integrating it and finding the values here, what I will get, I can very easily see that it will be 4 by 3 multiplied by 1 by 2 minus 1 by 4. I will again get here 1 by 4. These two will cancel out, and ultimately the answer of it will be 1 by 3, which is the required quantity or required probability of the question 3.47 part D. Okay. So that's it for today, in which I have solved two parts of the question 3.47. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.48, and it states that referring to exercise 3.39, find part A f of y given 2 for all values of y, and b probability of y equal to 0 given that x is equal to 2. Okay, so first of all, let me see that what is problem 3.39, and this is the exercise problem 3.39, and the statement of it is given here, and from it we can very clearly see that the oranges here are basically corresponds with x, and apples here are basically what? Y. Okay, these are also given here. If x is the number of oranges and y is the number of apples, so in the sample find the joint probability distribution of x and y, and previously we have found out that the joint probability distribution of x and y is given as what? That was 3 choose x, okay, 2 choice y, okay, and also 3 4 minus x minus y, okay, divided by the 8 choice 4. Okay, this was basically what? This was basically the equation for the joint probability distribution of x and y. So on the basis of it, let me solve this one, and in solving it, let me have it here, and to find the probability of y given 2 or y given x, that would be what? By using the conditional probability, we can have here f of 2 and y divided by the probability of x equal to 2. Okay, so on the basis of it we can find it here, and then we can find the f y given to for different values of y, and the values of y are basically what? These are 2. Okay, so all values for it would be 0 1 2, which means 0 apples, 1 apple, and 2 apples. Okay, so let me find out different values here, and the first value, which is g of 2, how can we find it out here? It can be found out by f of 2 0, okay, or f of 2 1, or f of 2 2. Okay, we can very easily find it out by putting these values over here. Okay, we can see that this is basically the value of x, y, this is the value of y. Okay, similarly this is x, this is y, and so on. So let me put all these values here, and putting them here I can find out here for the f of 2 0, what would we get here? It would be 3 2, okay, 2 0, and also here 3, and 4 minus x is 2 minus 0, so here 2 divided by what? Divided by 8 choice 4. Okay, so here finding it out, what will we get? It will be 9 by 70. Okay, so let me put it here. It will be 9 by 70. Similarly, f21, putting values here in this formula as well, what will I get? I will get 18 by 70, and also putting 2 2 here, what will be the answer? Here it would be 3 by 70. Okay, you can try it, and ultimately you will get what? It would be 30 by 70, which is 3 by 7. So the value of g of 2 is 3 by 7. Here using this equation, let me call it equation A, and using equation A, what I will get here, putting this 3 by 7 over here, I will get f y2 is equal to f of 2y multiplied by 7 by 3. Okay, so these are all the values which we had to find out. Now I have told you previously that the values of y basically ranges from 0 to 2. So let me put here the value of y equal to 0 given 2. So putting it here, I will get f2 0 multiplied by 7 by 3, and it would be what this is basically given here, and putting 9 by 70 here, which I have already found out by putting values here. So it will be 9 by 70 multiplied by 7 by 3. So it will be 7, 10, 3, 3. Okay, so it would be 3 by 10. Okay, so f of 0 2 is 3 by 10. This is what we had to find out. Let me move down somehow. Okay, similarly, here f of 1 given 2, that would be the value of y is equal to 1 when given that the value of x is equal to 2. So it would be 2 1 multiplied by 7 by 3. So it would be 1. It would, so it would be what? As we have seen that it is here. So 18 divided by 70 multiplied by 7 by 3. Okay, 3 6 and 7 10. Okay, so I will get here 3 by 5, and that is for f1 2, and also f2 2 is f2 2 multiplied by 7 by 3. So its value is also given, that is 3 by 70. So 3 by 70 multiplied by 7 by 3, these two will cancel out, while here I will get 1 by 10. Okay, so these are different values which are given. Okay, so in tabular form, which can also be tabulated here. So here if I have different values of y, and here we have f of y given to, so what I can do here is that let me have here the table in which the different values of y are 0 1 2. Okay, and also let me have here this table, and putting values here, what I will get for 0 I got 3 by 10, it was 3 by 10. For 1 it was 3 by 5, and for 2 it was 1 by 10. Okay, so this was what? This was the solution of part A of our question. Now moving towards the part B of our question, find the probability of y equal to 0 given x equal to 2. This is also similar to f of 0 given 2. Okay, so f of 0 given 2, let me see that whether I had found it out or not. Okay, this is already given here and this is here. So the probability that y is equal to 0 given that x is equal to 2, this is also the joint density such that y is equal to 0 given that x is equal to 2. Okay, that is already known, and this is here we had already found it out, and this was 3 by 10, which is what? Which is the solution of part B of our question. So that's it for today, and we can see that this was part B of our question, and we have seen the solution of part A and part B of our question 3.48. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. So this is question 3.49 of chapter 3. and the statement of it is, let x denote the number of times a certain numerical control machine will malfunction 1, 2 or 3 times on any given day. Let y denote the number of times a technician is called on an emergency call. Their joint probability distribution is given as a table which is given here. Okay, so you can see here that here the vertical lines basically shows the values of x, while here the horizontal lines basically shows the values of y. Okay, and their combined joint probability distribution has been shown as tabulated here. So on the basis of this table, part A of it evaluate the marginal distribution of x, B evaluate the marginal distribution of y. Okay, so let us first find the marginal distributions of x and y, and I have previously told you that in order to find the marginal distribution of x, what I have to do is to make the values of that variable constant. Okay, just like here, if I want to find the marginal distribution of x, what do you have to do? You have to make the value of x equal to 1 and then add them all together. If you want to find the marginal distribution of x at equal to 2, what do you have to do? You have to add all this column and here as well. Okay, so let me have here this one, and here in order to find the marginal distribution, let me have here x. Okay, and its marginal distribution, let me have here, this is g of x. Okay, so now the values of x are 1, 2 and 3. Okay, so these are basically the values, and what are their corresponding marginal distribution, I have to add them together. So here I will have to add 0 0.05, 0 0.05 and 0.00. So adding them all, which corresponds with x equal to 1, I will get 0.10. Okay, similarly for x equal to 2, what I will get, I have to add 0 0.05, 0 0.10 and 0.20. Adding them together, I will get 0.35, and for x equal to 3, I have to add 0 0.10, 0 0.35 and 0.10. Adding them together, I will get 0.55. Okay, this is basically the marginal distribution of x, and adding them all together, if you will add all these values, you can very easily see that these will be added to 1, which is the prime condition for any probability distribution. Okay, so that is for what? That is for x. Okay, so let me remove it and move to part B of our question. Okay, in part B, it is asking us to evaluate the marginal distribution of y. Okay, so this was A. Now let me move to B. So again, let me have here the different values of y, and let me have here h of y, which is for the marginal distribution of y, and let me put different values of y, which are 1, 3 and 5. Okay, so let me find them out, and here I have told you that in order to find the marginal distribution of that variable at any corresponding value, what do I have to do? I have to add them together. So here for y equal to 1, what do I have to do? I have to add these values, because you can see that here y is equal to 1. So adding them together, what will happen here? Adding 0 0.05, 0 0.05, 0 0.10, here we will get 0.20. Okay, similarly here, adding the values at y equal to 3, I have to add all these values in this. Okay, because now value of y is equal to 3, so 0 0.05, 0 0.10, 0 0.15 and 0 0.35. So what I will get here, let me have here this, so 0.50, and the last one here is at 5, y equal to 5, here 0 0.00, 0 0.20, 0 0.10, so here 0 0.30. Okay, so this is what, this is the marginal distribution for y, and again adding them 0 0.20, 0 0.50, 0 0.30, what I will get here, adding them together, I will get 1, which is the condition for the probability distribution. So this is, that's it for the marginal distribution of x and y. Now let us move to part C of our question, and here we have to find the probability of y equal to 3 given that x equal to 2 and this is C. So here I have to find out the probability that y is equal to 3 given that x is equal to 2. Okay, so in order to find it out, I have to use the conditional probability, and in conditional probability finding it out, I will have here the joint probability of x equal to 2 and y equal to 3, okay, divided by the marginal distribution of x equal to 2. So here I will have g is equal to x equal to 2. Okay, so let me put these values. From where they will I get this value? Okay, this value. So this value can be very easily found out. For x equal to 2, this is x equal to 2, and for y equal to 3, this is y equal to 3. So 0.10 is the value I have to put here. So 0.10 is the value I have to put here. And did I find out the value that g x equal to 2? Yes, this is already known, and this is 0.35. Okay, so 0.35 has been obtained from the values that 0.05, 0.10, 0.20. So adding them together, what I will get, I will have here 10 divided by 35, or 2 by 7. Okay, so that is what, that is basically the solution of part C of our question, in which we have seen the usability of marginal distribution, which is here, and also the joint probability distribution, which is here. Okay, and the ratio of them has been given me the conditional probability, which has been obtained here. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.
Hello guys, this is question 3.50 of chapter 3, and the statement of it is, suppose that x and y have the following joint probability distribution, which is given as a table here. Okay, so in on the basis of this table, what do we have to find out? We have to find the answers of part A and part B of our question. So in part A, find the marginal distribution of x, and in part B we have to find the marginal distribution of y. Okay, so previously I have told you how to find it out. This is basically the solution, and in solving it, what we did previously is that if you want to find out the marginal distribution of x, okay, so let me have here, this is part A, and if you want to find the marginal distribution of x, here I have to write x, and let me represent the marginal distribution of x as g of x. Okay, so we have different values of x. Okay, so here we have a table, and in this table we have 2 and 4 as the values of x. This is 2, this is 4, and here we have on. To find the marginal distribution of them, here I have to do what, these are the values, and on the basis of this table we have to find the marginal distribution of x at 2. So I have to add this value, this value, and this value, because this is at 2, and therefore I have to add all the values which are in this column. So 0.10 plus 0.20 plus 0.10, this is 0.4. Okay, so let me write it here, this is 0.40. Okay, and similarly for 4, this is the column which corresponds with x equal to 2. So here let me add them. So 0.15 plus 0.30 plus 0.15, so this is 0.60. Okay, so this is what, this is the marginal distribution of x. Similarly, to find the marginal distribution of y in part B, again let me have here y, and to represent the marginal distribution of y, I have here h of y. Okay, so this is basically the table, and what are the values of y? Here we have 1, 3, and 5. So let me write them, 1, 3, and 5. Okay, so these are the values. Now in order to find them out, let me remove them. Okay, and here in order to find their values, for y equal to 1, to find the marginal distribution of y, I have to add these two values. So it will be 0.10 and 0.15, this is 0.25. Okay, similarly for 3, 0.20, 0.30, so it would be 0.50, and for 5, these are the values, and adding them together I will get 0.25. 25 as well. Again, you can very easily see that by adding it, you will get 1, and similarly by adding them all, you will again get 1, which is the proof that this is a probability distribution. So that's it for today, in which we have found the solution for the marginal distribution of x and y for a given table of the joint probability distributions. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.51 of chapter 3, and the statement of it is 3 cards are drawn without replacement from the 12 face cards, which are jacks, queens, and kings of an ordinary deck of 52 playing cards. Let x be the number of kings, okay, and y be the number of jacks. So on the basis of this data, we have two parts. So let me first write the given data here, and in given data we have here the total number of cards, which are 12, and from these 12 I have to select 3 cards. Okay, so these 3 cards can be composed of x, y, or queens. So here I will have the representation of kings, okay, or the number of kings is x, and the number of jacks is y. Okay, while the remaining are the queens, which are basically x minus y. Okay, so we have x, y, and x minus y cards, and from 12 cards I have to select 3, and here the part A of this question is we have to find the joint probability distribution of x and y. Okay, so let me have a solution of this question. So solving it, this is part A of my question, and in part A the total number of combinations by selecting 3 cards from 12 which we will have here would be, this is basically the total, and it will be 12 choice 3. Okay, so finding the solution of it, I will get 12 factorial divided by 3 factorial multiplied by 12 minus 3 is 9 factorial, which is basically 220. So the total number of combinations which we can have here are 220. But in order to find the joint probability distribution of x and y, let me have here this f. So let me represent them with x and y. Here what we can do here is the combinations of 3 cards from x, y, and x minus y, which are coins, divided by the total number of combinations. Okay, so we know the total number of combinations, which are 220, but we don't know the combination of 3 cards. So let me have here, so initially the 4 cards we have are the kings. So king has 4 cards, similarly jacks has 4 cards as well, and the remaining queens are also composed of 4 cards. Okay, so dividing it over 220. But what should be here the choices? From 4 I can have x number of kings. Okay, from these 4s which are jacks I will have y number of jacks, and from this which are the queens, and we know that here we don't encounter the queens, so therefore the 3 cards here we will have the total, while from it I have to subtract the number of cards I have here. Okay, so let me correct it as well here. Okay, so here we will have these number of cards. So this is what, this is the formula for the joint distribution of x and y, and this is basically the essence of the question which we are going to solve today. Okay, so this is what we have. Now on the basis of this formula, let me draw the table in which I will write the joint distribution, okay, or joint probability distribution of x and y. So let me have here different values of x and y. So here we have x and here we have y. So y values are 0. Let me use another color for it, and yes, let me use this green one. So here 0, 1, 2, 3. Okay, why the 0, 1, and 3? Because here we can see that either x can have 0, 1, 2 or 3 values. Okay, here all the uh, cards selected would be king, or I can have here y where I will have here 0, 1, 2, 3, where this is the lowest value and this is the highest. It means 0 means no jack, while 3 means all here are jacks. So on the basis of this one, we can also write the condition for this as well, which is the x plus y will be greater or equal to 0, and it can also be less than or equal to 3, which is the lowest possible condition for this one. And this is basically condition for the formula which I have previously derived. Okay, so these are the quantities we have. Similarly for x, I can write here 0, 1, 2, 3. Okay, so on the basis of it, I have to make these selections and I have to write the formula. And in this formula, this 0, 0 is for f 0, 0. This 0, 1 would be for f 0, 1. This would be for f 0, 2, and so on until and unless we will have here f33. Okay, but remember that here I have to encounter all these values in which x plus y is at most equal to 3, while all the values which are greater than 3 are neglected here. Okay, you have to keep in your mind, like here I will have 3, 0. Okay, it will be included because 3 plus 0 or x plus y is within this range, while here if I will write 3, 1, so here x plus 1, x plus y, which is 3 plus 1 is 4, which is not in this range, so therefore we will neglect this one. Okay, so now let me remove them and let me write the values, actual values which we will have here. Okay, so let me remove it and let me draw this table again with this color. Okay, so this is what, this is the table. So now in order to write here the value 0, 0, let me write here 0, 0, putting this x equal to 0, y equal to 0 here in this formula. What I will get here, it would be 4, 0, 4, 0 again, and here x plus y 0, so 4 choice 3 and dividing it over 220. Okay, now solving them here, 4, 0 is 1, this 4 choice 1 is also 1, while this 4 choice 3 is 4. Okay, dividing it over 220, what I will get here, it will be 1 over 55. So let me write this value here, 155. Similarly for 0, 1, let me remove this 0 from here and write 1 here. Similarly here it will become 1 and it will become 2. Okay, so now this 4, 0 is 1, this 4, 1 is 4 here, while this 4, 2 is now 6. Okay, so now it will become 6 by 55. Okay, similarly putting now this for this is 0, 2, so this is 0, 2, this is 2, this is, it will become 1, and similarly changing these values, what I will get here, again here I will get 6 by 55. Okay, so you know that how to fill this table. Let me fill it out with the values I previously had found out. So it will be 1 over 55, similarly it will be 6 over 55, here 16 over 55. Okay, and this is again 6 over 55. This value will be neglected because 1 plus 3 x and y values are greater than this 3, which are 4, so I am neglecting it. Similarly here it will be 6 over 55. Okay, it will be 6 over 55 as well, while neglecting these two because 2 plus 2 and 2 plus 3 are greater than 3. And this is the last one where this is 1 over 55. Okay, so now this is what, this is the joint probability distribution of x and y, which is the solution of part A of our question. You have seen that how I have found out by using the formula which I have previously derived here. Okay, so similarly on the basis of all these things, I have to solve part B of my question, in which the probability of x and y, where this is the member of A and where A is the region given by x, y, such that x plus y is greater than 2. Okay, so this is part B, and I have to write or find the probability that such that x plus y is greater or equal to 2, okay, which can be found out by subtracting the other range of it, which is x plus y is less than 2 from 1. Okay, so let me see that what are the values here in which x and y and summation of them is less than 2. So this is 0 0 and 0 plus 0 is 0, which is less than 2. Similarly here 0 plus 1, this is 1, which is less than 2 as well. Okay, and this is 0 plus 2, this is not less than 2, while the equality condition is not given here, so this is not included. Similarly 1 0, this is 1 plus 0 is less than 2, and this is also included. So let me include these three values here and add them together. I will get 1 minus 1 over 55 plus 6 over 55 plus 6 over 55 as well. Okay, so it will be 1 minus, adding them all together, what I will get, 6 plus 6 plus 1 is 13, 13 divided by 55. So ultimately subtracting it from 1, I will get 42 over 55, which is the solution of part B of my question. Okay, so that's it for today, in which we have seen the solution of part A and part B of our question 3.51. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 3.52 and the statement of it is a coin is tossed twice. Let Z denote the number of heads on the first toss and W the total number of heads on the two tosses. Okay, so with the passage of this question, let me write the given data as well. Okay, so we have two tosses, the total number of tosses are 2. Okay, and Z denote the number of heads on the first toss. So Z denotes the number of heads in the first toss, which can be 0 or 1. Okay, and similarly W the total number of heads on the two tosses. So W is, it can be 0, no toss, no heads, 1 and 2, and 2 is the maximum value in which two tosses has the heads as well. So now in order to see that if the coin is unbalanced and a head has a 40% chance of occurring, which means the probability of heads is 0.4, which ultimately says that the probability of tails is 1 minus 0.4, and that is 0.6. Okay, find the joint probability distribution of W and Z. Okay, so that is part A. Let me solve part A of our question first. This is solution. Okay, and in part A of our question, let us denote the joint probability distribution of it as F, W and Z. Okay, where what is W? That is the total number of heads in the two choices, while Z is the head in the first toss. Okay, so values of Z can be 0 and 1, while it can be 0, 1 and 2. Okay, so now in order to find the probability of any event here, what can we do? We have to multiply the probability of heads in the two events. So for this also, let us have a table in which let us denote the, okay, this is a table, and here let us have Z and here W. So now the values of them are, the Z values are from 0 to 1, while W's are 0, 1 and 2. Okay, also let me draw it here as well. Okay, it is like this one. Now in order to find the probability or F 0 0, what does it mean? That the number of heads in the first toss is 0 and the total number of heads are also 0, so therefore the two tails has occurred. So therefore I have to multiply probability of tail multiplied by probability of tails, and that would be 0.6 multiplied by 0.6, which is 0.36. Okay, so the value here, let me represent it with this one. This is 0.36. Okay, similarly now, f the total number of heads here are 1, while the number of occurrence of the heads in the first toss is 0. Okay, so this is what we have, in which we can see that the second one will have the heads. Okay, so therefore I will have here probability of heads multiplied by the probability of tail. Okay, so it would be 0.4 multiplied by 0.6, so it would be 0.24. Let me write it here as well. So this would be 0.24. Okay, now this one is not possible. Why is it not possible? Because it is saying us that, let me write it with this color, that we have the total number of heads equal to 2, while in the first event or in first toss we have got 0 heads. So it is not possible, because in the second trial we cannot get a cumulative 2 heads. Okay, so therefore this one is not possible, so therefore we will leave it as it is, and it is not possible in this experiment. Now similarly, let me have here this one, and here it is saying that the cumulative is, let me write here as well this one, that it is saying us that the summation is 0, while in the first trial we have got 1 head, so it is again wrong, so it is again not possible here as well, so therefore we will leave this one as well. Now this one, here we have f1 1, in which it is saying that in the first trial we have 1 head, and the total number of heads after the 2 trials we have the total number of heads equal to 1. So therefore it is saying that in the first trial we have 1 heads, while in the second one we have tail. Okay, so let me write their probabilities. So it would be 0.4 and 0.6, so it would be 0.24. Okay, so let me write it here, the value. So it is 0.24 here as well. This last one, which is the value which saying that the total number of heads we have got are 2, in which the first trial has given me 1 heads. Okay, so what does it mean? It means that the 2 tosses has ended up with 2 heads, so therefore we will have here the probability of heads multiplied by the probability of heads. Okay, so here we will get 0.4 multiplied by 0.4, and it is 0.16. Okay, let me write it here as well. So 0.16. Okay, so that's what, that is basically the joint probability distribution for the event which is given here. Okay, so that is the solution of part A. Now let us proceed to part B of our question, and it is saying that to find the marginal distribution of W. Okay, let me solve it here. To find the marginal distribution of W, let me have here W and all the values of W. So we can see that the values of W are 0, 1, 2, and its marginal distribution, let me represent it with G of W. So here it is. Now in order to find the marginal distribution of it, we know that what do we have to do here? We will add all the values for 0 here. Okay, then all the values for 1 here and all the values for 2 here. So adding them together, 0.36 plus 0, here we will get what? Here we will have 0.36, because 0.36 plus 0. W for column 1, here we have 0.24 and plus 0.24, this is a single column, so adding them together we will get 0.48. Okay, and the last one here we have for 2, we have here 0 and this is 0.16. So here let me move it somehow here as well, so it is 2, so adding them together I will get 0.16. Okay, so it is here, this is for 2, this is for 1, and that's it. And adding them together I will also get that we will have here 1, which is basically the condition from the probability distribution, and that is what, that is the marginal distribution for W. Now for part C, we have to find the marginal distribution of Z, which is here the row wise items. So here we have Z. okay, and let me represent the values of it as h of z, which is the marginal distribution for z, and the two values of z are 0 and 1. Okay, now looking at it, we can see here that for this 0 we have to add these values together. So this is 0.36 plus 0.24 plus 0, so we will get here 0.60. Okay, now similarly for 1 here, we can see that we have to add all the elements in this row. So here adding them together, this is 0, 0.24 and 0.16. So ultimately we will get here what? The value of it will be 0.40. So that is the solution of part C of our question. Now the last part of our question is the probability that at least one heads occur. So this is part D, and we have to find the probability that the number of heads are greater or equal to 1. Okay, so here we can also find it out by 1 minus probability of heads which are less than 1, which is that the probability that heads is equal to 0, and this is only the value which is here. So let me put it here, and it would be 0.36. Okay, subtracting it from this one, we will get 0.64, and that is the solution of part D of our question. Okay, so here we can see that we have solved our problem in which we had, this is part A of our question, this was part B, part C, and this is part D of our question. So you have seen that how to find the joint probability distribution from a given statement, and then marginal distribution, and then conventional probabilities of certain events from that table. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.53, and the statement of it is, given the joint density function which is fx of y, and that is 6 minus x minus y divided by 8, which is for the x greater than 0 and less than 2, and y greater than 2 and less than 4, and 0 elsewhere. We have to find the probability that y is greater than 1 and it is less than 3, given that x is equal to 1. Okay, so that is what we have been given. In order to solve it, let me solve it first. Okay, in order to find the probability of y given x, we have to use the conditional probability, because here we have a condition that x is given. So in order to find it out, we have to use the conditional probability in which the joint density function is given as fxy and dividing it over the g of x. Okay, so this is equation A, and in this equation, let me first find g of x. Okay, so g of x is what we have to integrate the function which is here, which is 6 minus x minus y whole divided by 8, and integrated with respect to y. Therefore I have to write the limits for y, which are 2 to 4. Okay, so let me integrate it, and it would be the constant outside, and here we will have 2 to 4, and the function here would be 6 minus x minus y, okay, and dy. Okay, this is also the bracket. Now in order to solve it linearly, let me put it here, and it will be like 6 will be outside, 2 to 4 dy, also minus x will be constant for y, so therefore it will be y 2 to 4 dy, while for this y I will have 2 to 4 y dy, and here it is. Okay, so let me solve it, and it would be 1 by 8. Here we will get 4 minus 2, because here we will get y, so let me do it first. Here we will have y 2 to 4 and minus x, and here again y 2 4, and here we will have y square divided by 2 and 2 4. Okay, let me put these values, and here we will get 1 by 8, and here 4 minus 2, 4 minus 2 is 2, and 2 multiplied by 6 is 12. Okay, here again 4 minus 2, so I will get here 2x. Okay, here what will I get? It will be the 1 by 2 constant. Okay, and 4 for 16, 16 minus 4 is 12. Okay, so it will be what? It will be 6 here. Okay, so 12 minus 6 would be what? This will be 1 by 8, and here 12 minus 6 is 6, 6 minus 2x. Okay, or ultimately what will I get? Here we will get 1 by 4, and here 3 minus x. Okay, this is what? This is the g of x what we have here. Okay, so let me take it and put it in equation A. So in putting it in equation A, we will have y given x, and here we will have fx of y is 6 minus x minus y whole divided by what? 8. Okay, and dividing it to a what? 3 minus x, okay, whole divided by 4. So ultimately what I will get? It will be 6 minus x minus y dividing it over 3 minus x. Okay, and also this 8 4, so I will get here 2. So this is what? This is for the probability of y given x. This is the equation. Now in order to find these values here, let me put the value of x equal to 1 here. Okay, so putting x equal to 1, what will I get here? It will become y given x equal to 1. Okay, this is step 2 in which I have been putting the value of x here. So putting value of x here, I will get 6 minus 1 minus y dividing it over 2, 3 minus 1. Okay, so here I will get 5 minus y whole divided by 3 minus 1 is 2, 2, 2, 4. So this is what? 5 minus y divided by 4. This is for the probability of y given x equal to 1. Okay, let me move down somehow, and the last step here is to find the probability within this range. Okay, so what will I have to do here? I have to find the probability that y is greater than 1 and less than 3, given that x equal to 1, and the value of it is already given here. But in order to find this value here, in order to find it out, what do I have to do? I have to integrate this function from these values. Okay, so I have to do what here? I have to integrate the values from 1 to 3, but as we can see here very clearly, let me see the limits of y within this density function. We can see that it starts from 2 up to 4, so therefore this 2 will not, this 1 will not be available here. So I have to start it from 2, and as the ending point here is 3, so therefore it will be 3, and therefore I have to put the values which are here. So it will be 5 minus y divided by 4 and integrating it with respect to y. Okay, so here putting the values here, it will be 1 by 4, and also it will be 5 2 3 dy, and also here minus 2 to 3 y dy. Okay, so this is what we have. Let me move down somehow, and here solving it, I will get 1 by 4, and 3 minus 2 is 1. Okay, because here I will get y, so 3 minus 2 is 1, this is 5. Also here this is y square divided by 2, so 3 minus 2 would be what? Let me put this value here. Y square divided by 2, this is 3 to 2. Okay, this was y here, that's why I have solved it very easily. So 1 by 4, okay, 5 minus, this is 1 by 2. Okay, so 3 3 9, 9 minus 4 is 5. Okay, so it will be here, so 5 minus 2.5 would be 2.5 divided by 4, or it in your book the answer is 5 by 8. So it can also be written as multiplying the numerator denominator by 2, I will get 5 by 8. So that is the solution of the question 3.53. Okay, so what was the essence here? First we have found out the probability of y given x, then putting the value of x equal to 1, we have found the value for x, and then at the end we have found out the values for the ranges of y, and that is basically found out by integrating the given values or the values we have found out from the given ranges. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 3.54, in which we have to determine whether the two random variables of exercise 3.49 are dependent or independent. Okay, in order to see that what is meant by dependent or independent, so the two random variables are independent if and only if fx of y, which is the joint probability distribution, is equal to g of x multiplied by h of y. If this condition holds for all values of x and y, then those random variables are basically independent of each other. So here we have to check the same property for the random variable which we have seen. So let us move to question 3.49 and see what was given there. So this was basically question 3.49, where we had this table, and let me remove it. Okay, in this table we can see that those were all the values of f of x, while g of x values were calculated. So this is question 3.49, and here we can easily see that this is for fx of y, while these are for g of x and h of y. In order to see that whether the two random variables x and y are independent or dependent of each other, what we have to see? We have to see that whether fxy is equal to g of x multiplied by h of y, whether this condition holds for all the value of x and y or not. Okay, so if any one of the value doesn't satisfy this one, so it means the two variables are dependent of each other. So okay, so let me first find it out for x equal to 1 and y equal to 1. Okay, so which means we will have here f11 will be equal to what? It will be equal to g1 and h1. Okay, so f11 is equal to what? You can see that f11 is 0.05. Okay, so f11 is, let me put 0.05. The value of g1 is equal to what? Let me see here that what is the value of g1? That is 0.10. So here it is 0.10, and multiplying it with h1. So what is the value of h1? h1 is 0.20. Okay, so multiplying them together, these two will be multiplied together, and multiplying them together you will see that these two values are not equivalent of each other. Okay, so f11 is not equal to g11, which says that the two random variables x and y are dependent of each other and these are not independent. So that is basically the solution of the question 3.55, which we have previously seen. So let me move to that question, and this is the question 3.54, in which we have seen that two random variables x and y are not independent and these are basically dependent of each other. Okay, similarly you can apply the same concept for question 3.55 as well, where checking this formula for all values of x and y will show you that whether the two random variables x and y are dependent or independent. Okay, so let us also see question 3.50 as well. So this was basically the question 3.50. Here, in order to check that whether x and y are independent or dependent of each other, we have to check that here the value of x is 2 while the value of y is 1. So we have to check that whether f21 is equal to g of 2 multiplied by h of 1 or not. Okay, so what is f21? That is 0.10. So let me put it here, 0.10, and the value of g of 2, that is, let me see, that this is 0.40, 0.40, multiplying it with h of 1, 0.25. Okay, 0.25. So when these two will be multiplied together, we will see that it will also be equal to 0.10. Okay, so it says that the first values, two values are equal, so it shows that the one pair of values are equal. Similarly, for the second value, you can also check it for, let me check it for this one. So here 4 1 should be equal to g of 4 multiplied by h of 1. Okay, so f41 is equal to what? That is 0.15. Okay, and what is g4? This is 0.60, and h1 is what? This is 0.25. Okay, so when you will multiply it, you will also see that this will also be equal to 0.15, and that is basically the proof that at these values, these two when multiplied together will give me the answer, which is equal to fx of y. So you can also check it for all the values of x and y, and you will see that all these values will satisfy the equation fxy is equal to g of x h of y. Okay, so which is the proof that the two random variables x and y are independent of each other. Okay, so let me move to the main page, and here question 3.55, the two random variables are independent of each other. Okay, so in question 3.54, the two random variables were dependent of each other, while in 3.55 the two random variables were independent of each other. Okay, so that's it for today, in which I have illustrated the concept of dependence and independence of the two random variables. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 3.56, and the statement of it is the joint density function of the random variable x and y is fxy 6 for x greater than 0 and less than 1, and y greater than 0 and less than 1 minus x, and this is 0 elsewhere. So on the basis of this given data, part A show that x and y are not independent. Okay, so let me solve it, and the solution of part A is, first we have to see that what is the condition for the independence. Okay, so the two variables or two random variables will be independent if x y will be equal to g of x multiplied by h of y. Okay, if this condition is satisfied for each value of x and y, then those random variables will be independent of each other. Just like here x and y, we have to check that whether this condition lies or not. So for this, first we have to find out g of x and h of y here. So in order to find g of x here, what do we have to do? We have the random variable 6x, so we have to integrate it, and integrate it with respect to y. Okay, so the y range basically starts from 0 and ends at 1 minus x. So let me take this and ends at 1 minus x. Okay, so let me take it, and here integrating with respect to y, this 6x will be treated as the constant, so it will be out of this integral. Okay, and 0 1 minus x, and here dy. Okay, also here 6x, and here we will have y 0 1 minus x. So ultimately the g of x will be what? G of x will be 6x 1 minus x. Okay, this is for g of x, and here we have it. Okay, this is for g of x. Now let me take it for h of y. So for h of y, we have to integrate the same function, which is 6x, but we have to integrate it with respect to x. Okay, so here we can see that the limit of the limits of x are given, but in order to put the variables here, we can see here that y is less than 1 minus x, y is less than 1 minus x, okay, or let me use another color for it. Let me take this color. So y is less than 1 minus x, so therefore x is also less than 1 minus y, okay. Treating them as it is, we can see that the range of x is also from 0 to 1 minus y. So let me put them here as well. So I will get here 0 to 1 minus y, okay. I hope you have got my point, that here this is greater than 0 and similarly here this is, so therefore this condition lie here as well, okay. So let me integrate it, and integrating it, this will be 6 multiplied by x square divided by 2, and here it would be 0 1 minus y, okay. So here we will get 2 3, okay, and also 1 minus y square, and this is what, this is h of y, which we have just found out, okay. So these are the two variables we have found out. Now in order to see whether condition A lies or not, so for fx fy we have 6x, okay. We can see that this is fxy is 6x, okay. Let me multiply g of x and h of y, okay. Let me put their values, 6x 1 minus x multiplied by 3 1 minus y square. We can see here very clearly that fx of y is not equal to g of x h of y, okay. You can see that here this one and this one, these two quantities are not equal, so therefore the two variables x and y are not independent, okay. Basically these are dependent of each other, and you can also see it from this equation as well, that the value of y basically dependent upon the value of x as well, so therefore these two are dependent of each other, okay. Let me move to part b of my question, and here in part b we are asked to find x is greater than 0.3 given that y is equal to 0.5, okay. So again we have to find the probability that x is greater than 0.3 such that y is equal to 0.5, okay. Let me put their values, and as you can see that this is the conditional probability, so therefore I have to put here fxy and also dividing it over this h of y, okay. We have the values of both of them, this 6, this is 6x, okay, as given in the statement of this question, and hy is already calculated, and this is where it is. Let me see, here it is, okay. This is 3 1 minus y whole square, or we can also see that this is 2x divided by 1 minus y whole square, okay. As the value of y is already given and that is 0.5, so we can also see that putting it here we will have 2x divided by 1 minus 0.5 whole square, okay. So finding it out, we will have 2x divided by 1 minus 0.5 is what, that is 0.5, 0.5 square is 0.25, okay. Now in order to find different values for x here, we can see that when x is greater than 0.3 and the value of y is also 0 is equal to 0.5, we have previously seen that x basically ranges from 0 up to 1 minus y, which was given, okay. As the value of y is now given, you can see that this is now here 0.5 and that is greater than 0, means now the value here is replaced by here, because x must be greater than 0.3, so the new value of x will be from 0.3 up to 1 minus y, so 1 minus 0.5 here, because the value of y is already given. So taking it, the range of x will be from 0.3 up to 0.5, because here we can see that the lowest value here is 0.3 and the highest value of it will be 0.5. So therefore we have to find out the probability of x greater than 0.3 and less than 0.5, given that y is equal to 0.5. Okay, so in order to find this value here, okay, in order to find out this value here, what do I have to do? I have to perform integration within this limit. So it will be from 0.3 to 0.5, and the value here it is 2x divided by 0.25 d of x. Okay, so now let me take it out. This is 2 by 0.25. Okay, and integrating it, what I will get, I will get here x square divided by 2, and here 0.3, 0.5. Okay, so these two will cancel out. Okay, so now solving it, what I will get here, it would be 1 over 0.25 and multiplying it with the value 0.5 square minus 0.3 square. Okay, so calculating it, what you will get here, you will get 0.64, which is basically the answer of my question. Okay, so that's the answer of part B of my question, in which I have basically found out the probability that x is greater than 0.3 given the value of y 0.5, and I have also find it out by using the conditional probability theorem. Okay, so that's it for today, in which we have solved question 3.56. If you have any question, you can ask me in the comment box. See you soon.